Hello everyone, and thank you for joining us today for the webinar Building an Enterprise-Grade Virtual Infrastructure as a Service. Today's webinar is organized by StorPool Storage, and we have some very special guests and friends, which are Simon and Alex from Crystal. Hi Simon, hi Alex.
Hey guys, how's it going?
A few organizational things in the beginning. The webinar today will be approximately 45 minutes. We will have Simon and Alex who will present their newest project, Catapult, and they will share a little bit more about how they have built their enterprise-grade virtual infrastructure as a service. We also have Alexander Ivanov, who is a product lead at StorPool Storage, and who will give you a little bit more information about what are the latest things at StorPool and how you need to build your data management platform for the 21st century. During the webinar, you can write your questions on the chat window, which should be actually on your right-hand side. We will try to answer all of the questions at the end of the webinar, and also be sure you stay till the end of the webinar because we have some very cool present for all of the people who are here from Catapult. Let me go to the next slide. So I will give the word to our speakers so that they can present themselves with a few words. Maybe Simon, you can start.
Sure thing. Thanks, Yvette. Yep, my name's Simon Blackler. I'm the CEO at Crystal and Catapult. And that's really exactly what it says on the slide. So that's me.
Thank you, Simon.
And I'm Alex. I'm Crystal's CTO, responsible for technical operations at the company. And Catapult is our baby that we've been working on for many years now. At this point, that we're looking forward to showing off how we're making use of StorPool and its fantastic capabilities.
Thank you, Alex. Alexander?
And we're really looking forward to seeing it, Alex. So hi, everyone. Alexander Ivanov, the product lead of StorPool, as it says on the slide.
A little bit more about today's agenda for the webinar. So we will have the introduction to Crystal and Catapult, as I'm not pretty sure if all of you are actually familiar with them as a company. If that's the first time in which you're meeting them, be sure you ask all of your questions and use the time during the webinar. Simon and Alex will present what is Catapult, how they have built it, how they choose the right technology stack, and how they made their storage choice. Also, we will have a live technical demo of Catapult, which I'm pretty sure will be quite interesting for the tech people who are currently at the webinar. Then Alex from StorPool will share some tips on how you can actually compare your public cloud performance. If you are building infrastructure as a service, what is the right methodology in which you can compare your performance with the market leaders? And then we will reveal a little bit more about the performance of Catapult versus leading public clouds, and what is the price performance ratio which you actually can also achieve and which Catapult achieved. So don't forget to write your questions. And now I'm giving the word to Simon from Catapult.
Well, thank you very much, Yvette. So first of all, welcome to everybody, and thanks for giving up your time. If it wasn't obvious already, this is my first time ever doing a webinar, so please go easy on me. Crystal, simply a company I set up when I was 17 with a view to sort of trying to change the world. Nice, easy goal. We're a web hosting company. We've got about 30,000 clients, and we are really all about sort of transparency, quality, honesty. And that's why we're called Crystal, because those are things that crystals have. I just spelled it with a K to differentiate us in the search engines. I think at the time, Crystal with a K bought about 14,000 results, and now it brings back about 85 million. So I'm not sure how effective that differentiation is anymore, but that's why we're called Crystal. We're basically we're technologists. We really like building the best things we can, and we like being open and transparent in what we do in business. As I said, we've been running Crystal for about 18 years now, and a few years ago we recognized the need for us to have our own sort of hypervisor cloud platform, as our workloads were getting bigger, and we were getting tired of having to just keep on replacing the hardware and lifting and shifting clients. It was going to become a really big problem. So we looked around the market to see if we could get an off-the-shelf cloud solution, but everything that we looked at, we found was not good enough for one reason or another. And so eventually we decided what we should do is build our own. And so that's what we did. We started working on Catapult probably 3 years ago. It's effectively a no compromise cloud platform. That's the sort of cloud platform you'd build if you just wanted to build the best thing and you didn't actually care about the commercials. So we looked at the market and we cherry picked everything that we could find that was the best, and then we sort of stitched it together and made it into what we call master crafted cloud. So it's our best version at what a cloud should look like if you didn't compromise on anything. So and then really the other part is that sort of Crystal's character and culture makes its way into Catapult. So everything we do is transparent, is environmentally conscious. So we've got all of our stuff's powered by 100% renewable energy. We provide stats, real-time stats on sort of the size and the state of the platform, and we do things that other providers don't do because we think it's just right, like include Ddos protection, include backups and or snapshots, and we just tried to build the platform that we would want to use because we have to use it. So that's basically that's Catapult. So the overview you're looking at here is actually just a snapshot from the website. It gives you some interesting sort of headline stats about the sort of size of Catapult. We'll talk a bit more about the actual ingredients that have gone into making this cake in a minute. At the moment, Catapult's only in the UK, but in the next couple of weeks, we'll be opening up 2 locations in the US, on the East Coast in New Jersey and on the West Coast in Phoenix, or at least West North America. And at that point, these stats should double. So what's Catapult made up of? Well, like I said before, we went along, we tried to cherry pick all of the best ingredients and then stitch them together lovingly to create a really nice product. We're running dual socket AMD EPYC Rome chips. We went for 32 cores at 2.9 gigs. We've got 1.5 terabytes of RAM in there, and we field 20 of these machines in a single cluster. So they end up being pretty monstrous. Each hypervisor can take 8 NVMe disks, and all of our storage is NVMe. And then each hypervisor has the ability for a Tesla GPU in it. So if needed, we can do ML AI workloads local to the hypervisor for maximum performance. But obviously this stuff needs to be connected, and so we picked Juniper for the routing core, MX204s, which are lovely bits of kit, and then we run 2 switch fabrics to connect the stuff. Each server, each hypervisor is multi-homed to both a internet fabric and a storage fabric dedicated to running StorPool. At the moment, the internet is twin 25 gigs, but we're upgrading that to 100 gigs, so it'll be 200 gig total. And the storage network is currently twin 50 gigs, but that'll also be going to twin 100 gigs. So again, 200 gigabits for each of those fabrics. We got DDoSed a while back, and it was a pretty unpleasant time. And as a result of that experience, we put in place a lot of DDoS protection, and we now make that available to all of our Crystal clients free of charge without them even knowing about it. And we thought it'd be really cool if a public cloud did that too. So DDoS protection is included in Catapult. You don't have to select anything or opt for it or pay anything extra. We just filter all of your traffic and make sure you don't get DDoSed. That includes a blend of upstream providers in the form of Voxility and Link 11. And then we also have on-site scrubbing in the form of a Carrero device. So between all of that, we've got a very robust anti-DDoS system. And again, it costs nothing. One of the features that I'm quite excited about going forwards for Catapult is free intra-site transfer. At the moment, as I said, we've only got the UK, but shortly we'll have sites in the US, and then we've got plans to expand to Amsterdam and Singapore, and probably also San Francisco, Frankfurt, Vancouver, and Tokyo as soon as it's practical. And what we're looking to do is create a network that connects all of these sites across the planet, which we're calling the Bifrost after the Norse bridge. And we will be providing intra-site transfer for free too. So you'll be able to have workloads in America or Europe and or the UK and move stuff between those sites without paying any ingress or egress fees like some of the big players do, which we think will be pretty cool and attractive. So having picked the sort of the servers, we went through a lot of design choices there, and then the network and a lot of design choices there. That really left, you know, the heart of the platform was storage. And you know, what storage do you pick? Because fundamentally, your user's perception of how fast your platform is going to boil down to how fast your storage is. So I'll hand over to Alex, who's the brains of the outfit, and he can explain a little bit about the storage choices we went through.
Thanks a lot, Simon. So we, at the point that Catapult was sort of in its kind of genesis, we sort of had the sort of standard choices, I guess, with storage platforms that you would typically expect. So we, as a sort of historically as a shared hosting provider, we have some experience using traditional SAN appliances. We've been long-time users of NetApp devices. So our default starting point into the market of how to provide a cloud infrastructure platform really kind of started with looking at traditional SAN storage appliances. Obviously, there are a huge range of SAN devices available. Most of them tend to have pretty good track records. They're well supported. They tend to have a good feature set, a lot of software capabilities on them. However, what they lack substantially is flexibility. They're relatively inflexible in terms of being able to scale, being able to deploy new locations. They also typically tend to suffer from inability to scale performance. Generally, it's very easy with a SAN. If you've got a SAN appliance and you need to add additional storage, you add an extra shelf. That extra shelf is giving you the throughput capacity of the disks that you've added in the shelf, and also the additional storage capacity of that shelf. But the controller is often a bottleneck. In most use cases, those controllers, obviously, depending on the controller model and the SAN you use, those can be scaled up, but you typically have to right size that from the beginning. So you're basically left with a relatively inflexible platform where effectively the cost to entry is either very, very high, or you're left with an appliance that has relatively modest performance. So basically, because of the flexibility requirements that we wanted in terms of being able to deploy Catapult, we very quickly ruled out traditional SANs and started looking into software-defined storage systems. At the time that we were looking, there were various software-defined storage platforms that were sort of offering or advertising the kind of features that you would expect, that they're sort of linearly scalable performance, that they're incredibly flexible, that they run on commodity hardware. One of the examples at the time is now part of Pure Storage that we looked at was CompuVert. We'd had some pretty good recommendations of the software, and it ticked all of the boxes on paper for us in terms of sort of flexibility and scalability capabilities. We ran into major problems with the software, though, that it just did not live up to the performance expectations. Despite spending months talking to CompuVerd's support staff who provided fantastic support with the software, it wasn't living up to the promise of software-defined storage in terms of performance. So we kind of moved on from there into looking into open source alternatives. Obviously, these are relatively attractive from a sort of basic upfront point of view in that they're free. They're readily available, they're well supported by the community, they're consistently updated, and there's no upfront cost involved with them. Ceph obviously is a market leader in this. Ceph has been around for years. A lot of large enterprises make use of Ceph. The major problem with Ceph, or one of the major drawbacks that we determined existed with Ceph, is the fact that the total cost of ownership over time is actually very high, because you're having to maintain the sort of expertise in-house to be able to maintain that system forever, regardless of what may come in the future in terms of potential problems, gotchas, needs and requirements to update. The risk with using an open source piece of software like Ceph is basically just that. It's effectively a never-ending pit of time and human resource rather than necessarily cost. So we did carry on down the route of looking into commercial software-defined storage systems, and this is where we came across StorPool. And to not put too fine a point on it, when preparing this slide earlier, we really struggled to find anything to put in the cons column here, basically. From our perspective, StorPool really ticks absolutely every single box that we had been looking for in terms of a storage system. The performance is absolutely stellar. I'm not going to touch too much on the performance of StorPool here itself. I think Alexander has some info about performance later, and it's a fairly standard message. It performs incredibly quickly, fast. General performance across the entire clusters is fantastic, and it lives up to the promises, basically. We also found, from talking to StorPool's team when we began engaging them very quickly, that their support is absolutely excellent. Not really touched on so far here, obviously, is resilience of your storage system, because it kind of goes without saying, when you're building a storage system, regardless of whether it's for an infrastructure as a service platform or almost any other platform, your storage has to be available and it has to be resilient. That's literally job one of a storage system. And for us, what it came down to in choosing a storage system is we wanted to be able to sleep easily at night, knowing that our infrastructure platform was going to stay online and keep our clients' data safe, because their data is the thing that our clients entrust us with, and we need to ensure that that data is safe and that it's always available. With StorPool, we have never had any concerns in that regard. The software is entirely 100% resilient, to the point where we have performed entire power offs of racks of servers consisting of entire StorPool clusters in the past, and the clusters have successfully rebuilt themselves and reorganized and come straight back online. With solutions like Ceph, the same can never be said. I have horrible memories of having performed the same test with a Ceph cluster and then spent hours afterwards trying to get the clusters back online, because these pieces of software often don't work in the way that is generally advertised and that meets the sort of promise of software-defined storage. StorPool does, basically. So with that in mind, I thought it would be nice to basically give you guys a quick demo of how we're actually making use of all of the various features and functions that StorPool includes within the software. So rather than just touching on performance, just touching on resilience, sort of have a look at how the actual features that the storage system provides can be used and how we're leveraging them within our cloud. So I'm going to
Thank you very
take
much,
there.
Alex. Yeah, you can share your screen. And I will just say once again that our friends from Catapult are so generous to give us a credit for everybody who is attending the webinar and who would actually would like to try a virtual machine or the Catapult performance. So stay till the end and we will give you a code for testing Catapult.
Thank you. So with luck, you're now taking a look at part of our Catapult console.
Yep.
We're going to give you an ever so slight peek behind the curtain here because I'm actually logged into the system via effectively a super admin account. So we've got a few features and functions in here that a user of the system would not see, but they do provide a little bit of insight into some of the features and functions within StorPool and how we're using them within the system, really. So to start off with, in terms of actually building and launching virtual machines, we are making use of StorPool's snapshot capability for this. So any operating system templates that we deploy within Catapult are deployed as snapshots within the StorPool storage system. When a machine is deployed, those snapshots are then broken out into a fresh disk, and the machine is then built from those disks. So I've got a few machines here that we've spun up in advance of this. If we navigate into one of these VMs, something that a lot of users coming from sort of internal enterprise cloud platforms like VMware will be readily familiar with, but a feature that's generally not seen in public infrastructure as a service platforms is, because we're making use of clustered storage that's hyper-converged within the hypervisors or the compute nodes that make up Catapult, we have the very easy ability to live migrate VMs between hypervisors. This is basically leveraging StorPool's multi-attach capability. Basically, whenever we want to live migrate a machine between hypervisors, the system basically calls out to StorPool, multi-attaches the disk onto the target compute node that we'd like to move it to, then a KVM migration is performed, and then on the back end, on the StorPool layer, we then make sure that the original snap or the original mount for that attachment is no longer in use, at which point that mount is cut off. So we then end up with the system back onto a single non-multi-attached mount on the new hypervisor. So within Catapult, we can simply auto-select from one of our range of hypervisors. We then get a very quick task that's running through the process of performing the migration. The migration's underway there. There was about a third of a second for the storage operations to happen, and we've now moved that VM seamlessly onto a new hypervisor. Obviously, the storage platform makes this incredibly straightforward and easy for us, which was exactly what we wanted out of the storage system that we deployed, basically. We also make use of StorPool's snapshot system. So beyond just deploying disks, we provide snapshots available to customers at any time. So a customer can literally generate a snapshot within the control panel, and the StorPool system, in that amount of time, the snapshot that's been created is there and available. That's taking a snapshot directly onto the StorPool system using its own capabilities. So it's a fully differential snapshot that will only reflect any changes in disk space or size between the time the snapshot was taken and any changes to the live machine. We then obviously support the ability to redeploy the VM from that snapshot, which again is just making use of StorPool's capability to convert that snapshot back into a live disk and boot the system from it. Going a bit more in depth into the snapshot capabilities coupled with StorPool's multi-site capability, the Bifrost private network that Simon mentioned earlier, we already have in place between data centers in the London area. We're making use of these for backups, effectively. We currently operate backups off-site, running to a separate StorPool cluster. This is making use of a combination of generating a local snapshot on the system and then using StorPool's inbuilt multi-site capability to replicate that snapshot out to an off-site StorPool cluster. StorPool does actually now have a capability built in to carry this entire process out called volume care. But as coincidence would have it, we were designing and building and orchestrating our backup system at the same time as volume care was actually in development by StorPool. So we've effectively ended up replicating their entire volume care system within our own orchestration. But now that entire process is simplified because StorPool has that capability built in. It can, if you've got multiple clusters or you're in a position to deploy multiple clusters, they can be linked together by, in our case, we're using dark fiber connections, but essentially any internet connection can link those sites together in a multi-site connection to be able to replicate snapshots and disks between clusters as needed. So yeah, that basically touches on our use of the snapshot system. Not currently integrated into Catapult's capability, largely because we are still testing the safety aspects. But we do have the ability to both grow and shrink disks online. As of now, Catapult will not perform these changes online, basically because we're essentially coming back to data safety here. We're largely fairly wary of performing partition and file system changes to an online disk, but StorPool itself, the underlying storage system behind this, is fully capable of growing and shrinking these drives online with absolutely no interruption to user operations. As things stand at the moment, we carry out these changes offline, so we require a disk to be detached and a VM shut down, at which point we can then basically either grow or shrink a volume as needed. Again, this is an innate feature of StorPool that's incredibly useful. Both the grow and shrink process take a fraction of a second each. And from that point on, it's then just a case of having to manipulate both the partition table and the file system on that disk. But the underlying system does fully support performing this online with absolutely no interruptions. So just taking a look at some of the administrative capabilities and flexibilities that StorPool provides, in terms of providing fair resource usage to drives and to end customers, we have a series of disk I/O profiles set up. We have so far struggled to find the practical limit of IOPS on StorPool's platform because it's almost untestably high. But we've currently settled on as a sort of reasonable starting point for users. We currently deploy disks with the capability of using 100,000 IOPS at any given time. Thanks to the underlying storage system, we aren't having to carry out this IOPS accounting at the hypervisor level or within KVM. This is being done directly on the storage system. So at any time, we basically have the ability to, this particular drive has two profiles available. We can either give it 100,000 IOPS or we can unrestrict it entirely. And that's literally a completely instant operation, which is simply sending a call to StorPool's API to change effectively the performance profile that we have set for the disk. StorPool carries that out entirely on its back end and provides very good accounting for the throughput capability that you provide on the disk.
Yeah, I would just say that we basically, as Alex said, been having discussions about, what's a reasonable amount of IOPS to allow to a machine, and it looks like from our testing that you can get about 100,000 IOPS from a single CPU server. So we think that probably what we're going to do is settle on giving our base ROC 1, because it's a Catapult, obviously it launches things, so we've called our systems ROCs and boulders. I don't know if you can show that, Alex, but effectively our smallest ROCs that you launch are going to have a 100K limit on them, and then we're thinking that as soon as we get up to 2 cores and beyond, by default we'll allocate something like 200,000 IOPS, which is 20 times more than you get on other providers. But of course, the actual system can perform much higher than that, and it's one of our intents to actually make this make Catapult sort of available for people looking to build HPC or very intense environments in a hosted on a hosted platform. And so we're going to be able to vary the IOPS for large machines or for specific users to go up into potentially millions of IOPS, which is quite exciting to just be able to say, yeah, if you've got one CPU, if you've got one core, have 100,000 IOPS, and if you've got more than that, have 200,000 IOPS, and then if you need more than that, just let us know and we'll figure something out. But so yeah, anyway, I just thought I'd add that as a sort of aside. It's really quite, I don't know. I think Gandhi said something like there's more to life than increasing its speed. And there probably is, but it's a good place to start.
Yeah, absolutely. So in terms of features and capabilities within StorPool and how we're leveraging them, I really just had one more to demo for you. Catapult, as far as we provided out to the public, is entirely NVMe. Are the StorPool clusters that we sell out to consumers 100% NVMe throughout. As Simon mentioned, the genesis of Catapult really was also an internal system for us. So a lot of Crystal's workloads have been making their way onto the Catapult platform over the years. We maintain our own cluster within Catapult that is not exposed to end users, but which we can use for our own workloads. And this makes use of StorPool's effectively multi-pool or multi-tiering system. So the storage hardware that we deploy onto our internal cluster has both standard SSDs and also NVMe's in it, which we split out into two separate storage tiers. So within the cluster, we literally have the option of deploying virtual disks onto SSDs or deploying them onto NVMe's, depending on whether effectively for our use case, whether we need large volume storage, in which case it's going onto SSDs, or if we need the lowest latency, maximum throughput we possibly can, in which case we're deploying onto NVMe's. One of the very useful capabilities that StorPool provides, though, is the ability to online promote and demote disks between those storage tiers. So we've exposed that capability into Catapult. Within a disk, we literally have the option to change a disk's storage speed. And at the moment, the disk is on NVMe storage. We can literally just reselect it onto SSD storage. And again, this is literally just passing this operation directly through to StorPool and telling it, hey, we want to demote this disk from NVMe down to SSD. We change the storage tier, and that change is underway live with no impact on user operations. In this case, the disk is very small and that process is already completed. In that space of time, the disk has been demoted from NVMe storage down onto SSD with absolutely no slowdown or interruption to the disk whatsoever. Again, this is just an incredibly useful feature that StorPool provides that we basically wanted to expose into the Catapult system to really give us the maximum flexibility that we possibly could out of the system, and to really sort of leverage these advanced features to provide value to customers. And on that note, I think that concludes the walkthrough of how Catapult is making use of the various features and capabilities that StorPool provides. So I'm handing over to Alexander.
Thank
that was
you very
really
much,
cool,
Alex.
Alex.
Yeah.
Go on, Yvette.
Yeah, thank you very much, Alex. It was really impressive, and we're actually very happy to be part of your success. And I'm pretty sure that Catapult has a very bright future, especially with the expansions, which Simon mentioned. So now we will give the word to our product lead, Alexander. And I just want to remind that we will have a Q&A session at the end, so you can write your questions at the chat. Thank you.
We look forward to answering your questions, guys. So I will be a little bit brief, just so we have time for questions at the end, and so we can. I'm guessing that Yvette has some interesting questions for Simon and Alex as well. So and all of you in the audience also. So as part of our preparation for this webinar, we did a little bit of research into public cloud performance, and I wanted to tell you how we actually made an apples to apples comparison between Crystal and the hyperscale clouds out there. So The first thing that we did in the last few months was we decided to run the tests on an equivalent technical setup. We aim to do a 1 terabyte virtual disk for each virtual machine, about 16 gigabytes of memory, and about 8 vCPUs per virtual machine. Now, one of the things that you end up doing when you aim for this kind of setup is that you could have more memory on certain VMs, and in order to make sure in your own tests that you're comparing apples to apples, you should pre-allocate this excess memory into a file, basically even the playing field. Also, to make sure that storage is the factor that's influencing a given public cloud's performance, we recommend that you experiment with different sizes of workloads. So make sure that, for example, you try to run a database like test on less than memory, more than memory. Also try to run it on different quantities of vCPUs, just to make sure that the bottleneck is in, whether it's in the storage, in the memory or CPU and so on. Also, we need to make sure that we're working off the same cost basis. As you can see here, Catapult has the best price out of all the different public clouds out there for an equivalent VM like the one we show here. We haven't even considered the ingress and egress charges, which, as Simon mentioned, Bifrost is going to take care of that and make sure that Catapult is even more competitive in terms of price per month. And finally, what you need to do to run this performance comparison is you need to find workloads that are tests that are relatively similar to production workloads. So pgbench and sysbench are very good for database-like workloads, and FIO and rsync are tests that you can run to run these kinds of more synthetic benchmarks. So just moving on, I'm going to focus on pgbench here, the test that we did to measure how a given database is going to perform on this particular VM. As you can see, we ran two scenarios, one for a small OLTP database and one for a large OLTP database. So the small one is about a little bit less than the size of the memory, and the large one is 4 times the memory size. So here you're going to see especially how the performance of the storage is very much impactful on this one. So let me just show you the results. You can see that for the Catapult cluster that Simon and Alex were just talking about, the small database is running up to about 11,000 IOPS, transactions per second, I'm sorry, for this database test for the small virtual machine, whereas on the other public clouds like the Amazon EBS GP2 cloud, you can see that it's leveling off at about 2,000, nearly 2,000 TPS at the maximum of about 16 millisecond latency. And for the large database, again, you can see that Catapult peaks at about 10,000 transactions per second, whereas someone like Amazon would be peaking at about 1,500 transactions per second. Now, this combined with the cost, with the price per month for a virtual machine, means that Catapult can deliver up to 20 times better cost per transaction in a second. And I think that that's just really impressive, Simon, Alex. I mean, I was looking at this and I was actually shocked how good you are price performance wise.
Thank you very much. Yeah, it's good to see.
So with all that amazing stuff out of the way, I was thinking that we can close off with a very brief overview of what the core capabilities of a modern storage platform for cloud infrastructure should be. So we're only talking about block storage. That's where StorPool shines. We serve primary and secondary workloads with block storage over the StorPool block protocol as well as iSCSI. And when it comes to these kinds of workloads, the number one thing that's really important is reliability. Alex already mentioned it. You need to know that you have access to your data at absolutely all times. So even if you have secondary workloads, things like backups or archives, you need to know that you'll be able to get that data in a worst case disaster scenario. At the same time, you need to make sure that the data you put in is the data you get back. That's a little bit of an obvious statement maybe, but not many, no other solution has the end-to-end data integrity algorithms that we've put into StorPool to make sure that the data you put in is the data you get out. So no matter what happens, software updates, hardware bugs, any kinds of server network upgrades or firmware issues, all of that doesn't impact the data you've put into the storage system powered by StorPool Storage. The next thing that we need to consider is that even in a worst case scenario, like for example, a catastrophic power failure that just takes down the cluster, you need to have a durable system so that once the order is restored, your users can keep working from where they left off. Now, all these three together mean that you get the peace of mind that you have the infrastructure of your cloud infrastructure, the foundation of your cloud infrastructure is robust and stable. Now, that's important, but one of the important things that we believe is a fact is that your reliable infrastructure shouldn't rely on any specialized hardware to run. So that's why agility is the second important thing to consider. You must be able to install the storage software on any set of industry standard servers. The only thing you need to do is choose the right components for your particular use case. Now, anyone who has done this probably knows that it's not so easy to actually choose your components. And that's why StorPool helps our customers by selecting the right hardware for them. Our solutions architects take care of installing StorPool Storage, making sure that our operations team makes sure that they're monitoring proactively and maintaining the clusters of our customers. So things like updates and firmware updates are taken care of. We basically take it off the hands of our customers. Thanks to that, guys like Alex, and maybe you can confirm this, are basically simply use the storage. They don't need to actually all the time take care of monitoring and maintaining different technical aspects of it.
Absolutely, yeah. And StorPool also provides fantastic monitoring built in as well, which we do make use of. We leverage access to the monitoring system for trivial things like being able to actually display our amount of storage on the homepage of the Catapult website. But in terms of the actual sort of technical in-depths of the storage system, we have absolute peace of mind that it is monitored constantly by the StorPool team, and should there ever be an issue, they're always on it in a flash.
Yeah, thanks, Alex. The next thing that we always consider is that you need to be able to connect your storage to all the different hypervisors that you use, whether it's a custom hypervisor that you built, or whether it's VMware, KVM, Hyper-V, Xen Server. You also need to be able to, basically the storage needs to serve storage in a platform agnostic way to all the hypervisors at the same time. Finally, you need to be able to, as you saw earlier, actually during the demo shown by Alex, you need to be able to address any user requirements in flight, so without disrupting their workloads. This means that if you're adding drives or servers, changing settings like IOPS or virtual disk size, all of that must be happening online and seamlessly. With all that taken together, what you get is a storage platform that can grow with your business. We essentially make your business more agile and make it easier to respond to customer demands fast. Now, the final thing, all the reliability and agility in the world is basically great, nice, but a little bit useless if you don't have the performance needed to meet the demands of your users. So that's why StorPool is built to have no bottlenecks. StorPool is built in a way so it doesn't become the bottleneck in your cloud infrastructure. So the bottleneck is moved to components like the network and compute pieces of the whole environment. In this last point, I actually want to share the 3 core principles of StorPool storage. The first one is that we extract 100% of the performance of a given set of industry standard components in terms of latency, IOPS, data throughput, and we achieve this without depending on any specialized hardware. The second thing is that we aggregate all the speed of the drives in the system for all data in the system. So it doesn't matter if the data was written before you added a node, when you add a node, all of your data gets faster, all of your workloads get more performant. And then the final thing is that we scale the storage system linearly. As you add servers to a given system, the IOPS and throughput increase while the latency remains small. In particular, for NVMe drives, we're talking about 120 microsecond latency for reads. And that's on the front end, not something that we're measuring at the storage drive level. This is what we deliver. And essentially, altogether, this package of capabilities is what makes customers like Crystal trust us and use us for their cloud infrastructure. So thanks guys, and I'm going to actually hand it over to Yvette.
Thank you very much, Alex. Maybe you can just scroll to the next slide, where the next one, please. We have included some useful resources, which we will send to you after the event, after the webinar, together with the presentation and maybe a link to the recording. And our friends from Catapult, maybe Simon, you can share a little bit more about the credit which you would like to give to the participants.
Yeah, certainly. It is kind of as it says on the tin. Just take the code, punch that in, and yeah, you've got £1,000 credit to use within 12 months of when you sign up. We would love to get your input and feedback on the platform. We've got a Slack channel, so if you are technical, if you're interested, if you've got things that you'd like to do on the platform, please come join the channel. Come talk to us, put Catapult through its paces, and yeah, we'd love to invite you into the community and talk to you.
Thank you, Simon. So now it's the time for questions and answers. To make it a little bit more interactive, if somebody from the attendees would like actually to join the webinar and to talk with our speakers, you can just write the message and I can allow you to talk. That's how it's written on Zoom. So if you would like to ask your question personally, you can go. And now the first question is, can you run containers on Catapult?
Alex, do you want to take that one?
So the short answer for that one is right this second, no. Catapult does have basically the next major feature releases within Catapult are a Kubernetes container engine on which we are then also building effectively our own app engine and app platform. And if I can ever so quickly share a screen, we're basically sort of working on the UI process of this at the moment. So this is less about the sort of the raw container engine itself, and more on the app engine that will be running on top of it. We've just literally got a couple of sort of UI designs that are currently in progress, how the sort of app platform is going to look, or is in the process of looking. We're aiming to launch this towards the tail end of Q1, possibly pessimistically beginning of Q2. And this will encompass both raw container management via Kubernetes and also effectively an app hosting stack built on top of that engine.
Okay.
So to qualify, you can run containers right now on Catapult inside VMs and then use your own orchestration, right, Alex?
Yep. Yeah, absolutely.
Yeah. So you can do that, and you can use something like Rancher, and then at a future point when we release KCE, it'll be possible to move those containers into a native environment. But yeah, by the end of Q1, so about 2 months' time, I would hope that we'd be able to get KC or the Catapult container engine live.
That's very cool. So you keep the rapid development of the platform. One question from my side is when you're like a company like Catapult building its own IaaS and you need to battle the hyperscalers like Google or Amazon, what is the strategy which you will recommend?
So is this specific to Catapult, or is this just more broadly? What do you need to keep in mind if you're going to try and take on the big
Maybe
boys?
more broadly, because I see that we have
Sure.
other companies, other cloud providers here at the webinar, so your experience maybe can be useful for them.
Yeah, I think I would. It's the same in any sort of business, isn't it? You know, something new comes along, it disrupts the market, it provides solutions or a novel approach and offers 10 or 20x better performance in some characteristic. And then eventually those larger players stagnate and they grow too big and they fail to innovate. And so then you can come along and you can add something that solves a problem that potential clients are having right now. You know, AWS is the de facto choice for many cloud workloads, but it is expensive, it's complex, it requires a sort of training course to understand their GUI. It charges for things that should be included, and it doesn't provide brilliant support, performance, or speed. So there's any number of areas, I think, where you can innovate if you've got a passion for it.
Thank you, Simon. Okay, so the next question, it's coming from Ilya Balashov. What is the average load on storage network?
One for you, Alex.
Sorry, was that what is the average load on the storage network?
On the storage network, yeah.
I mean, it really depends on you know, exactly how much work is going on at any given time, really. I mean, as Alexander will test, one of the main requirements in terms of making sure that the storage network is performant is low latency. So we maintain a directly connected network between all of the systems that we connect directly to StorPool. We're running that network at 100 gigabits. We are aware that that is complete overkill, basically. You know, we essentially took the approach of wanting to make sure that this is never going to be a problem at any point in the future. We absolutely didn't ever want the raw throughput and capacity of the network to be any kind of blocker as far as StorPool is concerned, because going right back to the start of the presentation, we didn't want to cut any corners whatsoever. We wanted it to be as performant as we possibly could. In terms of actual real world usage, we currently our StorPool storage network pushes a few gigabits across the entire network, and that's with hundreds and hundreds of VMs running on the system. Some doing fairly heavy workloads.
I think another, maybe it's hard to know exactly what Ilya's after, but maybe another way of sort of looking at it is each one of our hypervisors has 64 cores available to it, right? And how many of those cores are being pre-held for StorPool?
Yeah, so yeah, I mean that's a valid point. Our storage is all hyper-converged, so the storage exists within our compute nodes, and that's where StorPool is running. We aren't running a separated storage cluster, and StorPool effectively reserves 5 CPU cores on each of those compute nodes to run its storage. And again, you know, we've spec'd that number of CPU cores in mind for the fact that each of our hypervisors or compute nodes is capable of running 8 NVMe drives. So, you know, we've pre-allocated effectively real world usage. The actual CPU load on those pre-allocated cores is considerably lower, but we've basically shot for the worst case in terms of once we've got 8 drives that are fully populated and thoroughly busy within each compute node, the maximum that StorPool is expecting to ever be able to draw in terms of CPU capacity is about 5 cores. So that is completely reserved, unavailable to the rest of the hypervisor or to guests, and dedicated just to carrying out storage operations, so that they always have full CPU time available.
Yeah, so hopefully that answers your question, Ilya. I mean, on the sort of CPU side, nowhere near capacity. On the actual network connectivity, nowhere near capacity. And as I said before, we'll be putting it up to 200 gigabits just to overkill it. But it's an aim of mine that at some point in the future, we will augment the stats that are on the website, maybe to show more granularly, more insight into what's going on the platform in real time. So stay tuned. Hopefully that helps.
Thank you. A few more questions. So first to the question of Rafael. Yeah, after the webinar, we will definitely send you the presentation and slides and all of the information. Next question is from Hans. Except of performance, what are the key aspects to focus on so that you can build a great IaaS and be competitive on the market?
Hopefully I kind of answered that just a moment ago, Hans, with finding something that people are a pain point that clients are struggling with an existing provider. You know, that could be poor support, it could be low performance, but that's less of an issue. It could be a lack of features, it could be anything like that. It might be, you know, I think a big trend to watch is moving closer to users, and maybe latency. While it's performance related, it's not necessarily the performance of the cloud itself, but the speed at which someone gets a response. But I think each of us has an insight into a market or a situation that gives them a competitive advantage, and so it's really a case for you to look at what you know that maybe other people don't, or identify a group of clients that maybe isn't currently identified, and service them and try and be as specific as you can. So Catapult, for example, is born off the back of our experience as a web hosting company. We intrinsically know what it's like to be a web hosting company, what challenges there are, what difficulties there are, and we've been doing it for 18 years. So when we make a cloud platform for ourselves and others, it's going to be very good at servicing hosting clients. I don't know what you do, but whatever you do, you will also have knowledge that other people don't. So I would sort of look to that.
Yeah, maybe the formula for success is a good quality of the service and a personal attitude to each project and each customer. Okay, as we're quite running out of time, I will ask the last two questions and really ask for fast answers. The first one is coming from Harry, and which is most probably for Alexander. For StorPool, hi guys, you're amazing. Thank you. For multi-stack support, there are so many hypervisors like KVM, Xen. You have a team, for example, one team for KVM, one team for Xen. So basically the question is how at StorPool we manage with this kind of stacks development.
So naturally we have a focus. We have decided that we want to focus on what we consider the 21st century stacks. So this is things like CloudStack, OpenStack, OpenNebula, ONAP, running to Kubernetes, running together with KVM. That's our main focus. And for everything else, we provide support over our implementation of iSCSI.
Thank you, Alex. Last question is CPU usage is clear now. How much RAM is reserved for StorPool?
That one's a fairly simple one. We currently reserve in the region of about 15 gigabytes on our hypervisors for both storage and hypervisor operations. Of that, StorPool StorPool has reserved about a third, so we reserve in the region of 5 gigabytes of memory. And as far as we're aware, that's basically complete overkill for it. I guess Alexander might have a more sort of in-depth answer if need be about exactly how much memory in different circumstances StorPool uses, but we assign in the region of 5 gigabytes available to StorPool.
The best thing we can do without us is if you get in touch with us, we'll be happy to help you. As I mentioned earlier, we help our customers with the hardware configuration, so we can tell you exactly, for your particular use case, exactly how much memory you need.
Okay, so thank you all of you for being together with us today.
Sorry, yeah? That one thing. If you want to make use of the coupon, simply sign up and we will apply it to your account. Okay, so just top right of catapult.io. I don't know if I can share this with everybody, but if you go there, top right, you'll see a link. Click on that, sign up, and any signups that we see come in, over the next couple days, we will just upgrade to give 1,000 of your local currency, 1,000 euros, $1,000, £1,000, and you can test the system. And like I said before, if you'd like to join us on Slack, we would love that too. So
Thank you, Simon.
Thank you very much.
Yeah, as I said, we will send the presentation recordings. If you have any questions, don't hesitate to get in touch with us. You can write to StorPool or you can write to the Catapult guys. Also, when we close the webinar, there will be a short survey with only 2 questions. We will really appreciate it if you can fill in the questions. And yeah, stay tuned for our next events. Follow us on Facebook, on Twitter, on the social channels. We will be quite happy to reconnect with you again in the next days. Thank you very much and have a wonderful day. Bye.
Thank you.
So
Thank you. Cheers, guys.